Today we're going to talk about linear equations. We're going to write linear equations in different forms. We're going to write linear equations given different information. And then we're also going to look at parallel and perpendicular lines. A lot of this is review, but I strongly suggest you take notes over this material. Write down the examples so you can go back and look at them later. Pause the video if you need to. Let's go ahead and get started. The first thing is you need to be able to recognize when you're looking at a linear equation. A linear equation could be written in the form, if I were to replace this x with a 4 and the y with a 3, it would be 3 times 4 or 12 minus 2 times 3 or 6, and it would be 12 minus 6 equals 6. This is the solution to this equation because there are numbers that make it true. The solution set are all the coordinate pairs that make this equation true. When we graph it, they'll form a line. We've already talked about slope, and sure you remember that's rise over run, and we've got this formula right here. A linear equation's got a constant rate of change. It's got a constant slope. The slope of a line that goes up from left to right is always going to be positive, and the slope of a line that goes down from left to right is always going to be negative. And a horizontal line has always got a zero slope, and a undefined line is a vertical line. It's got an undefined slope. Some examples of nonlinear equations. Well, the following equations are not linear equations. And you need to be able to identify which ones are linear, which ones are not. It's pretty easy. We're looking for powers of only one. And this first one, obviously, it can't be. It's got a power of 2. Second one's got a radical. It can't be a linear equation. It's got actually a power of 1/2. This one, the x and the y get multiplied together. That will never happen in a linear equation. And then the last one, s divided by r, the variables get divided. That's never going to happen in a linear equation either. So x-intercepts and y-intercepts. The x-intercept is a point where the line crosses the x-axis. As a coordinate, it's always going to be some number and then 0, because the y always equals 0 for the x-intercept. It's not unusual for it to refer to it as its number. For example, in this case, we might say the x-intercept is equal to 15. The y-intercept is the point where the line crosses the y-axis. The x is always equal to 0, and then it'll be some number. So in this case, we might say that the y-intercept is equal to 3. Now, finding the x-intercept is pretty easy. All you've got to do is replace the y with a 0 and then solve for x. So in this case, if I did that, if I replace the y with a 0, it's going to say 2x equals 6, and then x is going to be 3. My x-intercept is going to be 3, 0. And then if you want to find a y-intercept, all you've got to do is the same thing, only you're going to replace the x with a 0. And so in this case, if I replace the x with a 0, it's going to say y equals 6. My y-intercept is going to be 0, 6. This can be kind of helpful when you're trying to find a quick sketch of a line. In this case, I've got x equals 4y minus 5. And if I try to find the x-intercept and then the y-intercept, I can graph those 2 points and then quickly sketch a line. So let's try it. In this case, let's try to find the x-intercept first by replacing the y with a 0. And then solving for x, we find out that x is equal to negative 5. So our x-intercept is negative 5, 0. And then if I do the y-intercept, if I substitute in the 0 for x, the y is going to equal 5/4. And so now I've got a y-intercept of 0, 5/4. And then all I got to do is plot those 2 points, negative 5, 0 and 0, 5/4, and then connect them with a line, and I've got a quick sketch of this graph. In this one, I've got g of x is equal to negative 3x minus 1. What I want you to do is go ahead and pause this, and then try to do this on your own, and then start back up again when you're ready. All right, so hopefully you did that. Our x-intercept is going to be negative 1/3, and then if I do the same thing for our y-intercept, I'm going to find out that our y-intercept is negative 1. If I plot both those points, I'm going to get this line right here. So try this one, 6x minus 3y equal negative 18. Pause it and find the x-intercept and the y-intercept, and then draw a quick sketch. All right, hopefully you did that. If I take the y and make it equal to 0, I find out that x is equal to -3, giving me an x-intercept of -3, 0. And then if I make the x equal to 0, I find out that the y-intercept is going to be 6. So I've got a y-intercept of 0, 6 and an x-intercept of -3, 0. If I plot both those points and then put a line connecting them with an arrow on each end, I've got a quick sketch of that line. So in this case, I've got x equals 3. Now, if I try to find the x-intercept, I'm going to have to make the y equal to 0, but there is no y. So the x is already by itself. X is equal to 3. So the x-intercept must be 3. This must be a vertical line because there's no y. It's never going to touch the y-axis. And if you try this, if I go to replace the x with a 0, well, then it's going to say 0 equals 3. Well, that's not true. This line never touches the y-axis. This is a vertical line going through x equals 3. And then, if I want to try to find the x and y-intercepts of y equals -2, we're going to run into the same problem. If I make the y equal to 0, it's going to say 0 equals -2, and that's not true. So there is no x-intercept. If I look for the y-intercept, well, the y is always equal to -2, and so then the y-intercept is going to be 0, -2. This is going to be a horizontal line. To summarize, to find the x-intercept, substitute 0 in for y and solve for x. And if you're looking for the y-intercept, substitute a 0 in for x and then solve for y. Slope-intercept form of the equation. You're probably familiar with this. Y equals mx plus b. M is the slope and b is the y-intercept. The y is going to be by itself. So if you've got a linear equation but the y is not by itself, all you got to do is get the y by itself. So graphing a line, there's two different approaches to this. One is to make a table and find some points and then plotting them and then connecting them with a line. So let's take a look at that. In this table method, what you've got to do is use the rule and find some points that make the equation true. So for example, in this case, if I plugged in a -2 for x, it's going to say 3 times -2 plus 2. Well, that's going to give me a y equal -4. And if I make x equal to 0, then y is going to equal to 2. And if I make x equal to 1, then y is going to equal 5. Those are all points that are going to make this equation true. So if I plot each one of those points, it's going to look something like this. And then all I've got to do is connect them with a straight line with an arrow on each end, and I've got a graph of that line. Now the other approach is to use the slope and the y-intercept. And basically the steps are to make sure that the equation is written into slope-intercept form, meaning the y is by itself, and then finding the slope and then finding the y-intercept. And then all you've got to do then is plot the y-intercept and then use the slope to find some more points and then connect the points and you got your line. So let's try it. We got y equals 3x plus 2. The slope is going to be 3 and the y-intercept is going to be 2. So if I go ahead and plot the point y-intercept of 2, it looks like this. And then if I go up 3 and over 1, then it's going to give me another point right here. And then all I've got to do is connect those 2 points with a straight line and an arrow on each end, and I'm good to go. Now if I want to find the equation of a line and they give me a slope and a y-intercept, well, that's the easiest situation, especially if I'm going to use slope-intercept form. So let's take a look at a couple examples. In this case, the slope is 2/3 and the y-intercept is -12. Well, if slope-intercept form is y equals mx plus b, all I've got to do is substitute the slope for m and the y-intercept for b, and I've got my linear equation. So in number 2, the slope is -5 and the y-intercept is -1. If I replace the slope with, or m with the slope and b with -1, it's going to be y equals -5x minus 1. And I can find the equation from a graph using the same kind of logic. If I could identify the y-intercept, in this case 0, 2, And then I can figure out the slope by using rise over run. In this case, it goes down by 3, and then it goes to the right by 4. So that means our slope is going to be negative 3/4. So then all I've got to do is substitute for the m, negative 3/4, and the b 2, and I get my equation. Now, if I'm going to write an equation in point slope form, that's a little bit different. It's just a different form to memorize. It's actually pretty easy if you remember the formula. It's y minus y1 equals m times x minus x1. The y1 and the m and the x1 are the things you substitute in. So for example, here I've got the 0.34 and the slope 2, and all I do is replace the x1 and the y1 and the slope in the formula. So let's try this one. Here I've got the 0.41 and the slope negative 2. So I'm going to replace the 4 and the 1, and then I'm going to replace the m, and I've got my equation. And then if in fact I want to write it in slope-intercept form, all I've got to do is distribute the negative 2 and then get y by itself. So let's try another one. Here I've got the point negative 1, 3, and the slope 7. If I plug it into this formula, I'm going to take the y1 and replace it with a 3, and the m and replace it with a 7, and the x1 replace it with a negative 1. Minus a negative is becoming positive. And again, if I wanted to rewrite it as slope-intercept form, all I've got to do is get the y by itself, and I'm good. Y equals 7x plus 10. Now find the slope-intercept form of the equation if I've got the slope negative 3 and the 0.42. Now I could use point slope and work it all down like we just did, or I can start with slope-intercept form and replace the m with a slope of negative 3. And then I could use the point, which is just an x and a y, in this case 4 and 2. And in my formula, replace the y and x with my y and x. And then all I've got to do now is solve for b. And in this case, it's going to be 2 plus 12, which is my y-intercept is 14. So now I know the slope, and I know the y-intercept. And so I can do like we did a few minutes ago and replace the slope and the y-intercept, and I get y equals negative 3x plus 4. Now let's try this one. I've got a slope of negative 0.25 and a point to negative 6. Again, all I'm going to do is take the slope and substitute it in for m, and then I'm going to take my point and substitute that x and y in, and all I got to do is solve for b. And once I know what my b is, well, then I'm going to rewrite my equation because I've got the slope and the y-intercept. I can put it in slope-intercept form. In this case, the b is going to be negative 5.5, and we already know the slope. It's negative 0.25. So all I've got to do is substitute those into y equals mx plus b, and I've got my equation. In this case, y equals negative 0.25, x minus 5.5. Now, if I want to find the equation of a line that has 2 points, well, I'm going to take the 2 points and I'm going to find the slope, and then I'm going to use one of the procedures we've just talked about a few minutes ago. In this case, we'll just find the slope, and it's going to be 4/5, and then we're going to plug it into the slope-intercept form, and that's going to be y equals mx plus b. We've got to pick one of the points. In this case, we'll use negative 2, 1. So now we're doing like we just did a second ago. Replace the y with 1 and the x with negative 2. Solve for b. Once you know what b is, you've got the slope and you've got the y-intercept, and all you've got to do is write the equation in slope-intercept form. In this case, it's going to be y equals 4/5 x plus 13/5. Now, if I'm going to write equations with parallel and perpendicular lines, well, you got to know what a parallel and perpendicular line is. So let's talk about that real quick. Parallel lines have the same slope and different y-intercepts. So any two vertical lines are going to be parallel. So we've got an example here, y equals 3x plus 1 and y equals 3x minus 3. These are parallel. Now, perpendicular lines, the product of their slopes is negative 1. And you've probably heard this, the two slopes are opposite reciprocals. a vertical line and a horizontal line are also perpendicular. So in this case, you'll notice if I take 4 and take the opposite reciprocal, it's negative 1/4. They're perpendicular. Here I've got two graphs. You'll notice the slopes are the same and the y-intercepts are different. Those are parallel. And again, 2, if the opposite reciprocal is negative 1/2, those are perpendicular. So let's try one. Here I've got to write an equation that's parallel to this one, and then it goes through this point. Well, since it's parallel, I know my slope is 1/2 because parallel lines have the same slope. And I've got a point, so all I'm going to use is y equals mx plus b and substitute in the x and the y, and I got my equation. So let's try a perpendicular one. My equation, it's perpendicular to negative 1/2 x. So that means my slope is going to be 2. And I've got a point, and so if I substitute it in to y equals mx plus b, along with the slope, I've got a new y-intercept of 4, and my equation is going to be y equals 2x plus 4. And now, if I'm going to do an equation that's parallel, and it's got 4x plus 5y equals 7, well, it's not quite so easy to identify the slope, but it's not that big of a deal. All I've got to do is get y by itself. I can find out pretty easily my slope is 4/5. Once I know the slope is 4/5, we can even plug it into point-slope form, substitute in the point and the slope, and we've got our equation in point-slope form. And again, if you want to distribute, you could rewrite it in slope-intercept form. Okay, thanks for watching. I hope that helps.